Hi, I'm Neil Feit of the SUNY Fredonia Department of Philosophy. Here I'm going to be doing some proofs in predicate logic, and I'm at the Power of Logic web tutor site. I'm going to go down to chapter 9. I'm going to try and do 4 proofs here. This movie is going to supplement 9.3 and 9.4, which adds in some of our QN rules, as well as some rules reductio ad absurdum and conditional proof from statement logic. But I'm going to start with 9.3. I'm going to try to do 4 proofs in between 15 and 20 minutes if I can. I'm not going to be able to exhaust all the types of arguments you might have to prove, strategies, and so forth, but hopefully this will kind of give you a feel for different types of strategies and tips and hints and so forth. So I'm going to start with 9.3d9 here. So I'm going to go to part D and go down to number 9. Okay. Okay, this argument happens to have 2 premises, so we're going to start with line 3 in the box here. Okay. I'm looking at my conclusion. I want to prove that there exists a C thing. Okay, I'm looking at my premises now. I see that I have 2 quantified formulas. Okay, so I'm going to have to use instantiation rules. I don't see anything else that I could do. And when I use the EI rule, I have to obey the restriction that the name or the individual constant that I put in for the variable can't occur in an earlier line of the proof. So I'm going to instantiate line 2, EI, before UI on line 1. So I'm going to take line 2, says something is a B thing. I'm going to call that thing A, say BA. Okay, and that will be 2 EI. Alrighty. Now, line 1 is a universal statement, and I can instantiate that, because when you instantiate a universal with the UI rule, there are no restrictions at all on what name, in this case it's going to be a lowercase a, what name you put in. Okay, AA or BA, then CA. Okay, so that's going to be a 1 UI. Do we care about getting things nice and neat? Why not? Okay. So basically I turned the existentially quantified formula in line 2 into an instance of it, and same thing with the universally quantified formula in line 1, an instance of that. Okay. I want to prove that something is a C thing, so if I could prove CA now, I could use our EG rule to get there exists an XCX. Okay, so that's my intermediate goal. I want to prove CA. It's going to be pretty simple given lines 3 and 4. What I could do is take line 3 and use the addition rule. Remember that? Line 3 says BA, so I could add on AA or in front of that. Okay, that's the old simple rule of addition, one of our implicational rules of statement logic. So that's a 3 addition. Now, lines 4 and 5 have modus ponens form to give me CA. 4, 5 modus ponens. Okay. And I could now take my last step. Line 6 says that CA. A is a C thing, whatever. Alfred is a chiropractor. So therefore there exists, oops. Trying to get a, oops. Forgot that it was the $sign that I need to get an existential quantifier. There exists an XCX. Okay, that is coming from line 6 by the EG rule. We're generalizing here. We're building up a quantified formula. So if I check that proof, hopefully I didn't make any typos. Okay, it tells me that it's a correct proof. No errors were found. Okay, I am going to choose another from exercise 9.3d. I'm going to scroll down a little bit further to number 17 here, okay? Also 2 premises here, so line 3 in the box. Okay, again I want to prove an existential here. I want to prove that there exists an x such that x is h. And line 1 is a universal quantified formula. Line 2 is not a quantified formula. Line 2 is a disjunction. That v there is the main operator, okay? So here's a little bit of strategy here. If I can somehow get this out of line 2, I could use our EG rule to get the conclusion. So that makes me think I want to do a disjunctive syllogism with line 2. And so what I want is the negation of that. I want sort of not universal GX, which really just means I want if I could get universal GX or not universal GX, I could use DS with line 2. So that's going to be my intermediate goal here. Okay, so here I go. Let me get started. Line 1 is a universal statement, so I can use UI on that. Let's give that a try. FA and GA. Okay, that's going to be a 1 UI. Okay. Let me take my GA, since that's what I'm going to work with here. Okay, I'll make that a 3 simp. Okay. Now, line 1 does say everything is an FG thing, and I've proved that A is a G thing in line 4. So let me try to use universal generalization on that. After all, if everything is an FG thing, then everything is a G thing. Let me try. That comes from line 4, UG. Okay, I'm going to check proof now just to see how that went. There was a problem with line 5. The generalized constant, a constant is the same as a name, individual constant, must not appear in any of the premises. Okay, the web tutor is telling me here that I have not obeyed a restriction on the UG rule. If you use UG to go from an instance of a universal to a universal, which is what we did from 4 to 5, you have to obey all the restrictions. And one of the restrictions is that the constant, or the name, in this case the name A, right, here, it can't occur in the premises of the argument. But if you look up here, it does occur in the premises here. Little a is in the premise of this argument. Okay, so I couldn't quite do what I did below. Okay, but what I can do, maybe I'll just go back. Okay, since a is a premise, I can't use UG from something with an a in it. However, if I just go back and, after all, line 3 comes from UI. There are no restrictions when using UI. So if I just change that A to a B, and hence that to a B, and then I use UG, okay, that's going to work. Okay, of course the proof is incomplete. I haven't yet proved the conclusion yet, but now my UG works because B is not in the premises of the argument. So I've obeyed the restrictions on UG. Okay, so now if I take 5 and I double negate it, remember double negation? Okay, 5dn. Why did I double negate line 5? Well, now what I've got on line 6 is the negation of the left disjunct of line 2. I could get HA by ds. So that's going to be a 2, 6 ds. Doing this quickly, but I did talk about it earlier. And now I've proved that thing A is an H thing, so therefore there exists an X. Oops, did the same thing again. There exists an X, HX. Oops, I want an X there. Okay, there are no restrictions at all when you use the EG rule. Okay, as long as you got any instance of the existential formula, line 7 is an instance of line 8, you're fine. So this is a 7 EG, and I think that's it. We've reached the conclusion. We should have a proof here. Let's give it a check. Okay, looks like we're okay. Congratulations, no errors were found. Okay. So there's another proof, in this case involving a premise that is not itself a quantified formula or even just the negation of a quantified formula. I'm going to go back to the chapter 9 menu here, and I'm going to go down to 9.4a. Do a proof from there. I'm going to go down and do number 6. Oop, across and do number 6. Okay, let's see what we've got here. This argument, valid argument, has only one premise, so line 2 is going to start our work in the box. Okay. What I want to prove here is a universal. Okay, so I'm going to want to use UG to finish off this proof. And to use UG, I'm going to want an instance of that universal. I'm going to want, for example, LA, then MA, and then by UG, assuming I'm obeying all the restrictions on UG, I'm going to move to get that. Okay. Notice that what I want to prove first, LA arrow MA, is a conditional statement. In this particular proof, I think conditional proof is going to be the easiest way to do that, and we shouldn't be scared of doing a conditional proof to prove a universal, because a lot of universal claims have as their main operator, after the universal quantifier, they have that as a conditional. Okay, so let's see what we could do. Line 1 is a universal formula. It's a quantified formula. I'll just use UI on line 1. So it means applied to thing A. If KA or LA, KA or LA, then MA. And that is a 1 UI. Okay? Again, what I want to prove here, if you remember what I was writing there in blue, is LA arrow MA. So in this case, let me start a conditional proof. In fact, let me put one of those vertical bars before. I'm going to make an assumption. I'm going to assume the LA part, assume the if of what I want to prove. So that's assume for CP. Okay. Still in the scope of that assumption. Well, now it's pretty easy to get MA, what I want to get, that addition trick again. So LA logically implies KA, LA logically applies KA or LA by addition. So that's 3 addition. Now I'm going to use that with line 2, so I'm still in the scope of that assumption. Okay, gives me MA. That's going to be what? 2 4 modus ponens, I hope. Oop. Okay. Now I'm outside. I've assumed LA. I've proved MA. So therefore, I could discharge that assumption and conclude if LA, then MA. That's 3 through 5 CP. Okay. If we were doing this out on paper, we would have a box that looked like that right there. Okay. We made an assumption in line 3. We derived MA in line 5. Therefore, if LA, then MA. Alrighty. Now, what I've proved here is an instance of my universal conclusion. Okay? Can I use UG and therefore say, well, line 6 says if A is an L thing, then it's an M thing. Can I conclude, therefore, is if anything is, an L thing. Oh, I want Z, the Z variable here. Just doesn't make a difference from the logical point of view, but just from the kind of syntactic point of view, it makes a difference. LZ, then MZ. Okay, have I obeyed the restrictions? Well, this is going to be a UG, 6 UG. When I use UG, the name, in this case, the the A in line 6, okay, it has to obey certain restrictions. It can't be in the premises. Well, I'm okay. There's only one premise. It has no name A in there. It can't be in a line that comes by EI. Okay, well, I haven't even used EI here, so I'm okay there. It can't be in the conclusion itself. It's not in the conclusion itself. It's not in that universal statement. And it can't be from an undischarged assumption. Well, it's in line 3, which is an assumption, but we've discharged that assumption on line 6. You discharge an assumption when you use a CP rule or an RAA rule. Okay, so we should be okay here. Okay. Yep, congratulations, no errors are found. I'm going to do one more in this video, and I'm not going to do a 9.4. I'm going to go down, I'm going to go over to 9.4b. I'll go over to B here, and I'll do I've selected number 5. Okay. 2 premises, so I'm going to start with number 3. A couple of things here. I want to prove the negation of an existential here. Okay, a couple of different ways to do that. You could do an RAA on that, assume that there does exist an Sx, and try to get a contradiction. Or another way is, I think the way that I'm going to do it here, is to note by quantifier negation, my conclusion is equivalent to for all x not Sx. Okay, so if I could prove not Sa and obey the restrictions on UG, I could do a UG to there, and then a Qn to get to my main conclusion. So I think that's what I'm going to do this proof. Okay. Another thing to note is that line 1 is a disjunction. That's the main operator of line 1. Okay. Again, it makes me think that I'm going to do something with disjunctive syllogism here. Okay. In fact, I'll go with another color here. Premise 2, the thing that I have to work with, if I use a Qn on premise 2, there exists an x not turns into not for all x tx. So if I use my Qn rule on line 2, I get that, which is the negation, check it out, of the right disjunct of premise 1, and I could get a disjunctive syllogism going. So I think the green stuff is how I'm going to start this proof. The blue stuff is how I'm going to finish this proof. Okay, so there exists an x not is logically equivalent to not for all x tx. In other words, line 2 says something is a non-t thing, so line 3 says not everything is a t thing, and we have a rule for that, Qn, quantifier negation. So line 3 comes from line 2 by Qn. Okay. Now notice that line 1 is an or statement, and line 3 is the denial, the negation of the right-hand side. So therefore, we could get the left-hand side. It's not the case that there exists an x, Rx or Sx, Rx or Sx. And that's going to be an old statement logic rule, an oldie but a goodie, ds. So this is 1, 3, ds. Okay. It's very important, again, I can't instantiate line 4. It starts with a tilde, not an existential. What I can do is do a Qn on 4. Qn is useful here. Change that negative existential to universal tilde, and then keep Rx or Sx in there. Okay. Qn is a equivalence rule, by the way, so we could do it even if it's not on the main operator. Which I guess it is on line 4. That's 4Qn, right? I hope. Up to line 6. Now, line 5 is a universal. I could just instantiate that. No restrictions at all. That becomes not. So we're dropping the universal quantifier and keeping everything but putting a name a in where I see a variable x. Okay, that's a 5 ui. Okay. In proofs with, predicate logic, we're not going to use too many equivalence rules, but, our new quantifier negation is one of them, obviously. Double negation sometimes comes in handy. We used that earlier. De Morgan's is one of them that we will use, and we should remember that. Line 6 is the negation of a disjunction, so that becomes not RA and not SA. De Morgan's is a good one to kind of keep fresh on, okay? That's a 6 De Morgan's, and 8. The reason I did that is I could just simplify not SA out of there. 7 simp. Again, simp is just an old statement logic implicational rule. Okay, I'm now at the point where I can finish the proof the way I started it. Okay, if I universally generalize, I've now proved that this thing A is not S. A is not a snake or whatever. So can I conclude therefore that everything is not S? Okay, well, 8 UG. I can if I've obeyed the restrictions on UG. So the name A can't be in a premise. Okay, it's not. It can't be derived from EI. Again, it's not. I haven't used EI here. It can't be in line 9 itself. It's not. And it can't be in an undischarged assumption. It's not. I haven't used any assumptions, made any assumptions. Okay? So now line 9 is okay. And now I could just QN that to get the conclusion. It's not the case that there exists an X, SX. So line 10 comes from line 9. Oops. 9 by, again, QN. Okay? So there we go. We've reached the conclusion. I'm going to check the proof. I think it's going to be okay. I hope it's going to be okay. And it says, congratulations, no errors found. Okay. I hope this video has been helpful on at least some of the sorts of strategies and techniques you're going to be dealing with in proofs with predicate logic, monadic predicate logic.